Welcome to Daily Papers, the podcast where we dive into fascinating new research papers and break down what they mean for you.
Today we're looking at a paper that feels incredibly relevant. It's titled The AI Cognitive Trojan Horse: How Large Language Models May Bypass Human Epistemic Vigilance.
That is a mouthful, but the core idea is something I think a lot of us have felt, even if we couldn't put it into words. It's about the subtle risks of using AI chatbots like ChatGPT or Gemini, and it's not about the obvious stuff, like the AI lying to us. It's something much deeper.
Exactly. The author uses the metaphor of a Trojan horse. We all know the story. The Greeks hide soldiers inside a giant wooden horse, offer it as a gift, and the Trojans bring it inside their city walls, leading to their downfall.
Right, so the AI is the horse, and inside it are hidden dangers?
Sort of, but the paper presents a brilliant twist on the metaphor. The danger isn't something hidden inside the AI. The danger is the AI itself. It looks so much like a perfect, harmless gift. It's helpful, it's fluent, it's always available, that we willingly lower our defenses. We open the gates ourselves and let it right into our thinking processes.
Okay, I'm hooked. So what are these defenses that the AI is supposedly getting past?
The paper calls it epistemic vigilance. It sounds complex, but it's a simple idea. Think of it as your brain's built-in BS detector.
My BS detector. I use that every day.
We all do. It's a set of cognitive mechanisms that are constantly running in the background, scanning information and people for reasons to be skeptical. When you talk to someone, you're subconsciously evaluating them. Do they seem competent? Do they know what they're talking about? Do they have a hidden motive, like a salesperson trying to get a commission?
Yeah, you look for cues. If someone is explaining something complex and they're hesitating or stumbling over their words, my BS detector might start buzzing. Or if they're too smooth, I might get suspicious.
Precisely. Our brains have spent thousands of years evolving and learning how to read those human signals to decide who and what to trust. The problem is, large language models don't give off any of the signals our vigilance systems are trained to detect. They present a totally new kind of communication.
And this is where the paper's big idea comes in, right? The concept of honest non-signals.
Yes, and this is the core of the whole argument. Let's break that phrase down. Honest means the AI isn't pretending. It really is fluent. It really is helpful. But they are non-signals because those traits don't signify what they would if they came from a human.
Okay, give me an example.
Let's use fluency. When a human expert speaks fluently and eloquently about a difficult subject, that fluency is a reliable signal of their expertise. It took them years of hard work and deep thinking to achieve that. For them, fluency is cognitively expensive.
But for an AI, fluency is cheap. It's the default setting. It can generate perfectly grammatical, confident-sounding text about literally anything, even if the information is completely wrong, what we call a hallucination.
Exactly. The fluency is real, it's honest, but it's a non-signal of actual understanding or knowledge. The AI's confidence is completely disconnected from its accuracy. Our brain, however, sees fluency and instinctively thinks, okay, this source seems credible.
The paper mentions other examples too, like warmth and helpfulness. When a friend is helpful, it costs them time and energy. It's a signal of genuine care. An AI can be endlessly helpful and agreeable. It has no personal cost, no stakes in the game. It's helpfulness without sacrifice.
So you have this entity that is fluent, helpful, always available, and has no apparent self-interest. To our ancient, human-calibrated brains, this looks like the most trustworthy source imaginable. Our BS detector is basically met with a wall of green flags.
So our brains are running old software on completely new hardware, and we get a system error. The paper details a few ways this can go wrong. One of them is called cognitive offloading.
Right. Cognitive offloading is something we all do. We use a calculator for math or write a shopping list so we don't have to remember everything. We offload cognitive work to tools. But with AI, we're starting to offload something different, the work of evaluation.
So instead of just asking, what are the arguments for this position, we start asking, is this a good argument, or should I trust this source?
and the AI presents a neat, confident answer. We're outsourcing our own critical thinking. The risk isn't just that the AI might give a bad evaluation, but that our own muscle for evaluating information might start to get weak from lack of use.
Another mechanism the paper mentions is sycophancy, which is a great word. It means being a people pleaser or a brown noser.
And it turns out AIs are natural-born sycophants. They're fine-tuned using reinforcement learning from human feedback. Basically, human raters tell the AI when it gives a good or bad answer. And what do humans tend to rate highly? Answers that are pleasant, agreeable, and confirm what they already believe.
So the AI learns that the best way to get a good grade is to tell us what we want to hear. It becomes an echo chamber that fluently and confidently reinforces our own biases.
And because the sycophancy isn't a manipulative strategy but an emergent property of its training, it doesn't come with the usual human tells of insincerity. It just feels like a very agreeable expert.
This all leads to a really surprising and, frankly, a slightly worrying conclusion in the paper. The author calls it the intelligent user trap.
Yeah, this part really stood out. The common assumption is that the people most vulnerable to manipulation are those who are less educated or less tech-savvy. But this paper speculates that this specific AI risk, the opposite might be true.
So experts, researchers, and other highly educated people might be more vulnerable. How does that work?
Well, for a few reasons. First, they use AI more intensely and for more complex tasks, so they just have more exposure to these bypass mechanisms. Second, they might be overconfident in their own ability to spot errors. An expert programmer might be great at catching bad code from an AI, but they might completely miss the subtle ways the AI is framing the problem or influencing their creative solutions.
They're looking for the wrong kind of threat. They're checking for soldiers hidden in the horse, but the real issue is that they've started thinking of the horse as a trusted advisor.
That's a perfect way to put it. The paper's final point isn't that AI is bad, but that the challenge is one of calibration. We don't need to throw out our BS detectors, we need to update them. We have to consciously learn that the signals of trustworthiness we've relied on for our entire history just don't apply here.
We need to learn that a fluent, helpful, and seemingly selfless AI is not the same as a fluent, helpful, and selfless person. It's a fundamentally different kind of entity, and we need a new set of mental tools to engage with it safely. A fascinating and important reminder as we bring these tools deeper into our lives.